to have hurricanes right in here. And then some of them turn away from the US and a lot of them come towards the US. So when I hear people saying, gosh, I wish we just wouldn't have hurricanes, again, not going to happen. I know what you mean by the statement, because trust me, I live here in Florida too, and I don't want the hurricane coming towards me. I don't want hurricanes going towards anybody. But remember what was here first. The weather was. We weren't. The weather was here first. The climate was here first. We were not. And so climatologically speaking, this is supposed to happen. Hurricanes are supposed to come towards Florida. They're supposed to come towards the southern part of the country and even the eastern seaboard. What happened yesterday, I actually heard one national news outlet. It made me so frustrated. They were like, this is not normal for a tropical storm to come up towards New York. And I thought, that's not true. That is normal. And exactly what it did is normal. It formed, it drifted north, it weakened as it drifted north because it ran into cooler waters, and then it made landfall and it spread a lot of rain that way. That is exactly what's supposed to happen. The problem in our mindset as humans is we don't want it to happen. If you have a house and you're sitting right here on the east coast of Florida, or you have a beautiful house in southern Louisiana, or you spent $1 million and you poke out here in the Cape Hatteras, you don't want that hurricane. I don't blame you. I don't either. But remember, it's going to happen. We don't have a choice in the matter. So you have all these tracks for 100 years that we have put together, and they're going to happen. The return period, or what we call the most common areas to get hit based on those 100 years of records, within 50 miles of any point of land near the coast, you can start to see where major hurricanes are more common. Southern Florida, kind of the north central Gulf region, and believe it or not, a lot of people don't know this, I worked in North Carolina, I grew up in the Carolinas. It's very common for eastern North Carolina to get hit. Almost to the point where, believe it or not, it's just as common, if not more common, in eastern North Carolina as it is in southern Florida. Crazy, right? Most people don't think about that, but it is. It's very normal for hurricanes to whoop, whoop, just like that, right up through here. Dorian, Matthew, I mean, I could go on and on and on. Hurricanes over the years. I worked in North Carolina in the 90s. We got hit so much. I can't even remember all the names. Floyd, Bertha, Fran. I mean, there's so many. Hugo came right up through here. I mean, there's just so many. In June, it's very normal for tropical storms to form first right here in the Gulf, because the Gulf kind of stays warm year round, and it's the first to warm up coming out of winter. And so I did a little research project on my own when I moved here 15 years ago, and I did research and I said, hey, within 50 miles of a point in Tampa Bay, how often does a tropical storm pass the Tampa Bay region? Do you know how often it is? It's every other year. Yeah. So don't think of it as a bad thing. If you get a May or June tropical storm, they tend to be weak. They tend to bring very beneficial rains. They tend to replenish our aquifers. They tend not to be a bad thing. Remember, it was here before us. The climate has always worked this way. And so what happens is people will really kind of freak out. They'll go, oh my gosh, we're getting a tropical storm and it's only May 30th. Okay, that's normal. This is about where they form, is right there. Once you get into July, you notice, okay, they can still form in the Gulf. And guess where the one Faye just formed? Not a surprise. Look, right there where that blue area is. But you also start to see a little bit of development out here in the Caribbean. It's just about the time when things are warming up enough and the wind shear starting to back off that you start to get development. In August, okay, look at how it really starts to flare up right in here. That's normal. Your water temperatures start to warm up. The jet stream now has gone much farther north, so the jet stream's farther away, so you have less wind shear, so all of a sudden you start to get more development. September, there's a reason why we call it the peak of the season. At my station, we're not even allowed to take vacations in September for a reason, because we know it's going to be really active in the Gulf, the Caribbean, the Atlantic, the Western Atlantic. It's going to be active everywhere. You just hope it's not going to hit land, but it almost always does. It's going to hit somewhere. Now here's the shocker that 90% of people don't realize. Maybe local Floridians, if you've listened to me for many years, you might know this, but a lot of people don't. October scares us the most in Western Florida. southwestern coast of Florida from, I'd say from about the Panhandle south all the way to the Keys, it worries us the most for multiple reasons. Number one, October is when you start to get those fronts that I described earlier in this talk, and they're coming farther south. So you start to get cold air intrusions into the southeast. At the same time, you have very warm air with lots of low pressure areas still in the Western Caribbean and in the Gulf. So when these fronts start to drop south, guess what happens? The lows come up and then they turn because of the cold fronts and they go whoop, just like that. That worries us because that is when we can get hit. And the other reason that it worries us is because guess what? In October, the mindset of most people is, I'm thinking fall, I'm thinking football, I'm thinking Halloween, I'm thinking, yeah, I can't wait for that first cold front to cool us down. And it happened in Hurricane Michael, just a couple of years ago. Nobody was really thinking. And on a Friday afternoon, I said, watch out, Panhandle of Florida. There is a storm that's going to develop down here. And when it develops, it's going to go due north. And it worried me because it was a Friday. And people in Florida on a Friday afternoon in October are only thinking usually one thing: beach, boating, let's go have fun. It's not as hot as September was. Let's get outside and enjoy the life. Hurricane Michael formed and it made a beeline north. And we all know the result. Hurricane Michael devastated east of Panama City. October worries us. And then by November, things die down. All right, things that limit tropical forecasting or tropical storms and hurricanes, and that we forecast: Saharan air, dust that comes over from Africa. You probably heard the hype and all the media lately about the latest Saharan dust plume. I'm not sure why everything gets hyped up more now than it used to. Maybe it's because of social media. Maybe because we have so many outlets, Twitter and Instagram and Facebook. Maybe that's why. I don't know if it's the 24-hour news cycle. I don't know what it is, but we've been talking about the Saharan dust plumes now for 30 years. But for some reason now people are really paying attention to it. So when this dust comes off the coast of Africa, which is very normal, has always happened, it helps to suppress tropical activity. It's like a big high pressure, okay? So it's not a bad thing. Now, we obviously don't want too much dust. It comes across the Atlantic and it makes for our skies to be hazy. Sometimes it can kind of mess with people's allergies. We also look for water temperatures. The warmer this water gets, the more potential there is for the hurricanes and tropical storms to be a little bit more intense. But I will say this, no matter what, there's always going to be warm water in here. So it's not like you can say, oh no, this year the water is 0.5 degrees warmer, so therefore we're going to get more storms. No, it doesn't work that way. You're not going to get more or less storms. But if one forms right here where the hottest water temperatures are, then yes, it is true, if that water temperature is warmer, that hurricane might be a little bit stronger. That's what matters. But no, that, as far as water temperatures, it doesn't determine how many storms we're going to get. There's a lot more that goes into that. There's things like fronts and currents and wind shear, which, speaking of, that's my next subject. Wind shear. What you're looking at here is upper level winds. Think of it as almost like jet stream winds, and they're flowing through the atmosphere. And see, it's just like currents, river currents, but in the atmosphere. They're all over the place. Don't worry, you don't need to study this map too closely. It's just basically an example of, hey, wind 30,000 feet high in the sky, it's up there, it's constantly moving. You don't notice it, but we do. It's up there. And why we talk about it is the stronger those winds are up above us, 15, 20, 25, 30,000 feet high in the sky, if they are really strong, they will rip the tops of these clouds apart. And hurricanes do not like that, because as the hurricane is sitting here on the water, trying to take all this warm water and send it up into this cloud, it gets really angry if you're constantly fighting against it. And so a lot of times what will happen is it'll just fall apart, or it'll weaken it. And we as humans love that. But the atmosphere has to always come back to equilibrium. And so one of the things that I want to make sure everybody understands is, I don't like hurricanes either hitting any land. I really don't. It really tears my heart up when I see things like Dorian and Michael. I take it personal. I really do, because I see the devastation. I've been through it. I've been through so many hurricanes and I see the devastation. But I want to make this very clear. The hurricanes have to happen. For some reason, as we get smarter and more technologically advanced, we tend to have this belief that we can control everything. You can't control weather, and you're not going to, and you shouldn't, because think of the globe's atmosphere as a big heat engine. If you take the heat and you disperse it into northern cooler waters, the engine properly runs. If you do not disperse that heat, it doesn't run properly, and you'll start to get weird, chaotic things on the planet. So this is normal. You want hurricanes to go from equatorial regions to northern, colder regions. That's what disperses the heat. All right, high pressure. Hey, we've talked about it, right? Now all of a sudden, you're going from 101 to maybe 102 to maybe even 200 level. Once you start to understand more on the weather, high pressures, you will start to watch me differently on TV. Over the years, I like to describe why hurricanes and tropical storms are going to move where they will. If you know where this high pressure is, and sometimes we'll call it the Bermuda high in the summertime, then you'll know that I will talk about a weakness. Hey, look, my fingers are even pointing at it. And I said, hey, look at this little weakness right here. This storm is going to try and search out that weakness around the western edge of this high pressure. So when we had Hurricane Irma coming at Florida, this high pressure moved down like this, and Irma went farther west because of that. We predicted it a long term out. We predicted it a week out, at least a week out, maybe a week and a half out. And we could see this high pressure building in. And I think that's actually what led to a lot of the anxiety, and I don't blame people, from Irma, is that it's almost as if as our technology advances, as our knowledge advances, and we get smarter as meteorologists, there's one bad thing that's coming from that. That is that now we are making people more anxious farther in advance. So for a week and a half, people in Florida had to sit there and worry and go, oh my gosh, it's coming towards us. What do I do? And a lot of people thought, well, maybe it'll go away. And we kept saying, it's not going away. This is one of those that's a perfect scenario. It's in a perfect warm water. There's no wind shear, and it's on a perfect path. We kept saying it, and we knew it was going to turn. Let me give you an example of a storm. Take Storm A. If I were to show you this storm out in the Atlantic next week, and I said, there's the storm path, that's what we're predicting. We're predicting it will come off the coast of Africa, build in intensity, and move like that. 99% of you wouldn't care, and 99% of the world wouldn't care, because there's nothing out here and nobody cares. Bermuda might watch it a little more closely, but I'll be honest with you, they're so used to hurricanes that they'd go, okay, that's nice. But nobody would care. Now, some ship captains would care because, you know, there's shipping routes that go out through here. But even them, they're used to going in massively high 30-foot waves, okay? So most people wouldn't care. There's a point to this slide, and some of you probably are already picking up on this. When I give a forecast out here in the Atlantic, it's amazing to me how people will email me and say, wow, you guys are really good at forecasting. And we go, yeah, we're lucky. We have advanced in 30 years to the point where we're a lot more accurate. So we can tell you exactly where that storm's going for the next week. Here's the problem. What if I took Storm A and put it there? That's Irma. That was the track of Irma. It's the exact same thing I showed you out in the Atlantic. But when I show you that a week out and you see it coming towards land, all of a sudden it changes everything, doesn't it? It changes perceptions. It changes people's attention. All of a sudden we had millions of people, even in Europe, people were watching us online and they were fascinated because, you know, they come and visit and people have vacation homes here and people, millions of people were watching us like, oh my gosh. Do you remember how complicated Irma was? We knew this path right here. We were like 99% confident. But remember how when Irma was coming, we said, we know it's going to turn north. We were confident, but we didn't know if it was going to turn north there, or there. If it's out here in the Atlantic, do you care? No, you don't care if it's here, here, or here when it makes that north turn. If it's coming for land, you care. That's what makes my job so hard. Are we really good at forecasting tropical storms compared to 20 years ago? Heck, even compared to 10 years ago. Yes, we are tons better, and we're going to keep getting better. But can I tell you the difference days in advance that it will hit either Miami or Key West? No, there's no way. Hence why we give you a forecast cone, which is actually, believe it or not, an error cone. You also have seen us show the spaghetti plot. This is very important, people. I want to make sure that everybody understands this. You will see a lot of meteorologists that don't even understand this. I'm telling you right now, a spaghetti plot can get complicated. Basically, what we're doing is each one of these lines, we have told a computer model, if I give you a different input, tell me what the output is. So if one model says it's going to move in a straight line, let me erase this. And this model to the farthest south, we gave it one input and it said it's going to go here. And then I tweaked it deliberately. And I said, okay, let's change it to where the wind shear is this value, the water temperature is this value, the moisture is this value, and the lower level winds are this value. Okay, change it. Now tell me where it's going to go. And it goes, whoop, now that's the output. And we go as a meteorologist, huh, okay, that's interesting. Let me tweak it again. Okay, I change all the values. And then it comes back with this, huh. And then I change all the values again. And it comes back with this, huh. You know what we're doing? We're being scientists. That's what scientists do. The problem is, and I've talked to my colleagues about this, in weather conferences and behind closed doors, this was good work. This was smart. We're trying to manipulate the atmosphere so that we get a good idea of, are we honing in on anything? Are we getting a good idea of, is there consensus? But somewhere along the way, somebody thought it was a good idea to release all this information to the public. And that's where the confusion started. I'm not an advocate to say we shouldn't show people, but I'm an advocate to say that if we're going to show it, we better explain it. And a lot of meteorologists do not explain it. They just plop it up and they go, see, little ziggy-zaggy lines all over. What's important to understand is you need to look for consensus. The outliers usually are not going to matter. They're wrong. What you need to look for is the center area. And do you see the center area a whole week out with Irma? Look at that. It went exactly where the consensus was. In other words, we kept putting in different input, different input, different input, different input, different input, keep changing, keep changing, keep changing. We're deliberately trying to fool it, basically. And you know what it kept coming back and saying? Doesn't matter. You can change it all you want. I'm going to the same spot. Okay? That's what's important. So what I kept saying on the air is, folks, I'm 100% confident this thing's going to come to South Florida. I'm not 100% confident on which side of the state or where in the state it will make that north turn. That's what gets complicated. The little nuances. Once you get down to a 10-mile difference, whew, that is so hard. A 10-mile difference out here in the middle of the ocean doesn't matter. A 10-mile difference between Miami, the Keys, here or there, all of a sudden it's like, whoa, that's a big difference. So sure enough, if you remember Irma, you remember what it did. It came to right here, exactly where we said it would. Now it's just a matter of, was it going to make the turn at Key West? Was it going to make the turn at Miami? Well, guess what it did? It went right up the middle. Went right up through the spine of the state. And so Tampa got hit with some stuff. Miami got hit with some stuff. The whole state got some stuff. Some people got more tornadoes. Some people got some storm surge. Tampa Bay drained out because we just happened to then end up on the western side. And instead of pushing water into Tampa Bay, it drained water out. It was fascinating. That was a perfect example of how a tiny little difference makes all the difference in the world. There is a whole week out, an actual spaghetti plot from the GFS American model. So what we did was we took the GFS American model and we said, let's give you 26 different inputs. Now go. And there's 26 different variations of the same model. Do you notice what this blue line and black line are? Do you see it right there? I'm drawing over it, by the way, if you're sitting at home watching. That is what we would call the mean. And guess where it went? Smack dab right there. So I've heard a lot of talk over the years of, oh, spaghetti plot, meteorologists don't know what they're doing. And they're just showing us all these lines because they don't know what's going on. No, it's the opposite. We're essentially doing science experiments on air with you. That's really what we're doing, okay? And the problem is it can lead to a lot of confusion. It takes time to explain this stuff. I mean, look at us. We're sitting here on an hour. It takes time to explain this stuff. The other thing that happened, I heard a lot of bad talk about, well, the European model is so much better than the GFS American model. In some instances, to trained meteorologists, that is true. We will tell you right now, the European model is better at some things. But you know what you're looking at here on the map? The European model. Does it look any better to you? No, it looks almost exactly the same. There's some that we're saying east, there's some that we're saying west, and if you were to take the mean, I know this is really, really cluttered and it's hard to tell, but if you took the mean, the average of all of them, guess where the middle was? Right there. And that's where Irma went. So what I'm trying to say here is there are some times where the European model wins out and it's a little better. There are some times when the GFS American model wins out and it's a little better. But from a trained meteorologist that is active every single day, constantly looking at this data, I can tell you right now, the European does not dominate the GFS American. It doesn't. That's just false. It doesn't. In some tropical scenarios, the European model is better. In some tropical scenarios, the GFS American model is better. As a trained meteorologist, that's my job to know which is better and relay that to you. It's not your job. And so what I saw some meteorologists doing the past few years is they were basically dumping it off on the public and going, well, you choose which one you want to look at. I don't think that's right. They shouldn't be doing that. What they should be doing is using 20 to 30 years of their experience, if they have it, and their education. And by the way, I get continuing education. I go to conferences all the time. And they should then say, hey, this is what we've learned from these conferences and from really smart scientists. This is what we've picked up on. Do you realize that the GFS American model did tons better at predicting Tropical Storm Faye this week than the European model did? Some meteorologists won't admit that, but it did. It did a great job. It predicted it about a week out. So there you go. James, how are we doing on time? We're right at 1 hour.
Doing really good. I think you can keep going. We haven't lost anybody yet. Everyone's just wrapped with.
Okay, we have a little bit more time. What I will do, gang, is I'm not going to go too long because I want to answer questions, but I am going to go a little bit longer because I know tropical is what people love. They really want to hear about it, so I'll go a little bit longer. This was a picture of Irma, satellite picture, okay? What I want everybody also to notice is that over the years, we've heard people say, oh my gosh, are hurricanes getting bigger? Or, oh my gosh, are they getting stronger? What we've noticed is there's not enough data yet to be conclusive on what's happening long-term with hurricanes. But I can tell you right now, with 100 years of data, there's no such thing as two hurricanes being the same, ever. There are similarities. Like you could say, well, Irma was kind of like a Katrina. Okay. You could say, well, Harvey's rainfall was like Allison's rainfall. You know, you can do stuff like that, but they're all different. Some will be lopsided, some will be larger in size, but weaker in winds. Ike was like that. Ike had a massive wind flow that pushed a lot of water into Texas, but Ike didn't have very strong winds. People stay right on the beach during Ike. Irma had really strong winds and a really big storm surge and was really large, but look at how big it was in size compared to Andrew that did tons more damage in South Florida. You see my point? So Charlie was really tiny in size, but did tons of damage. Irma was really spread out and large, but did very little damage except to some spots around the Keys. But the damage that it did do to trees falling and tornadoes and things like that was spread out over a much larger area because of its large swath. So it's kind of one of those, which do you prefer? Do you prefer that one area gets devastated with a really, really, really small eye, or do you prefer that tons more areas get some damage, but less concentrated damage? I would think most people would say, I don't prefer either, but you don't have a choice. So that's how they're different. This is a great graph. Gosh, I love this graph. All right, the red areas and the red little dotted areas. Let me get my little pen out here because this is somewhat hard to see. See this red dotted area? This red dotted area is essentially where you have the hurricane force winds encircled in, okay? So look how small Andrews was. And by the way, Charlie's was even smaller than Andrews. It was like that. Charlie's was tiny, but it did devastation where that hurricane force wind was. Look at Irma's. Wow, it was really spread out, right? And Katrina's was too. See, that's a perfect example of how the hurricane force winds can be different. They can be close in, they can be farther out. They're all different. Each one is going to be different, which is why when it comes to hurricane forecasting, apps aren't going to cut it. Websites aren't going to cut it. I love that we have all that. And I love that in 2020, we have apps, we have websites, we have social media, we have so many avenues to get the word out. But a human being is going to be the only one that can explain and interpolate everything with a hurricane and then send that information on. And during Irma, what I kept saying was, what matters is it has such a large wind field, it's going to depend on which side of the state it goes towards that will depend on storm surge. We care about a storm coming up like this from the Gulf to get storm surge over here. If a storm goes over here on the other side of the state, honestly, we really don't care about storm surge. It's not going to give us one. We only care about wind and rain, okay? So that kind of stuff matters. This is also interesting. There was a lot of talk about global warming and climate change during Harvey, because Harvey, that made landfall in Texas, produced tons and tons of rain. It has happened before. What determines how much rain is how large the storm, how much moisture, and is it moving? The problem with Harvey was it didn't move. It had no jet stream to move it along. It had no cold front to move it along. It just happened to move into Texas and it sat there. There were no wind currents to move it. So there's going to be a lot of talk in the next 20 years, there already is, about, well, how much could maybe the climate change play a role in the peak rainfall total? That's still up in the air. The scientists behind the scenes are talking about it. We're doing research at all the conferences we go to. But what I like to do is stay away from the political side of things. And instead, what I like to do is stay right in the middle and stay on the science part of things. And what I will say is anytime you get a hurricane the size of Harvey that is going to remain nearly stationary, you're going to get flooding rains. So we don't need to concentrate on, was it 60.5 inches or was it 58.2 inches? It doesn't matter. It would have flooded no matter what. Do you want to know what really matters? What really matters is, how are we building in 2020? Are we putting in too much concrete, too much pavement, and too many homes in flood-prone and flood plains areas? And are we building in places maybe we shouldn't have built, like swamps, retention areas, Everglades? You see my point? That's what this world is really going to have to concentrate on going forward. And the good news is I think we are. It's not all negative. I think we are doing a better job. I mean, when I've seen neighborhoods built here locally recently, I do see retention ponds being done the proper way. I do see where water runs to a good area first. It's cleaned, it's, you know, funneled, it's okay. So there are good things. When you look at Irma, it was a massive storm, but do you notice the rainfall? That's it. 20 inches was the peak, and yet it was a massive storm, but it was moving. It kept moving along. Maria, same thing. In Puerto Rico, it did devastation from a wind standpoint. 20 inches actually isn't that much rain for that big of a storm. See my point? So each one is totally different. Look at Charlie, by the way. I just had to show this. Here's Florida, okay? Look at little Charlie. Tiny little hurricane. It did so much devastation. But when Charlie was coming towards Florida and Tampa Bay was evacuating, back then, believe it or not, although this wasn't that long ago, our technology has advanced so much, we now would have a better idea where it would move. But back then, we didn't know, was it going to move like this or was it going to move like this? That tiny little difference. Well, it moved like this and ended up making landfall just south of Tampa Bay. You could literally be sitting in Pinellas County the day of Charlie and it was sunny outside. And then you could drive into Manatee County and go, it's fine. But what hurricane are you talking about? But as soon as you got down here to where it made landfall, it was devastation. And everywhere that storm went, it basically made a path. If you've forgotten this one, it basically made a path like this. Here, let me show you. It kind of went like that. And everywhere along this path, there was pure devastation. It was like a tornado across the state. Everywhere outside of its path really wasn't that bad. So it just goes to show you how every single storm is different. Look at this. There was hardly even any rain up in Tampa Bay. There were outer rain bands all the way out in the Gulf. There were these massive rain bands inland that went through Orlando. And look at the little eye. Look at that. Tiny, tiny little eye. Here, let me try and erase that and then change the color so I can, there you go. There's the little eye. It fit in the bay down there in Punta Gorda. Okay, it actually fit in the bay. That would be like saying a hurricane eye fit in the mouth of the bay. Isn't that crazy? It would fit under the skyway. That's how tiny it was. You could be on the skyway and be like, oh yeah, there's one side and there's the other side. But yet it was devastating. So that's why it was like a tornado. All right, James, I'm going to go ahead and stop there so that we can have more like a chit chat back and forth, answer some questions, and you can remind me if I miss something. Because what I've learned over the years is with a talk like this, there's a lot. I mean, this was 101, but I'm sure a lot of people are thinking, oh my gosh, this opened up the world now to I'm thinking of other things. So what do you want to talk about?
I think you hit it on the head. And we've been having a very active chat throughout, and you're doing so good. And several people have made a point to say how great you're doing. And one of our most recent was, we need more of this. So why don't we do a few questions at this point? And that might, stir some more questions.
Okay.
We had early on, and you did mention about the Sahara dust storms. Is that something that happens every year?
It does happen every year, and actually it's still happening right now. The plume that came through, what was it, about 2 weeks ago now? Might even be 3 weeks now, time's flying. That plume, I will admit, was excessively large. There was a big wind pattern that came across Africa, so it was a little bit larger than the average plume. But yes, it is normal. I've talked about it in past years. And it really is just a matter of, do people notice it? Do they not notice it? I think it was just last year or 2 years ago, we had a very similar plume that came across. And the difference was we didn't make that big a deal about it on social media. And I mentioned it on air. And my news director came running back, which is a news manager. And it was like, oh my gosh, you mean that's why it's hazy outside? I was like, yeah, it is. And they were so fascinated. Sometimes as meteorologists, James, we don't realize how fascinated other people are. So we just kind of go, yeah, it's a Saharan dust, no big deal. We forget almost like, oh yeah, we probably should write a blog on it, social media on it, talk more about it. So what's happening is we're talking more about this stuff because we're realizing people are really interested in it. But we're talking about it more. It doesn't mean it's happening more. It's happening about the exact same, at least from what we can tell. And so then it's just a matter of tracking it. And we luckily have great tools to track it now. I can tell you where all the dust is. I can tell you how thick it is. And I can even almost to the point tell you the day it will arrive here.
That's so cool.
It is, isn't it?
And yeah, we can totally relate because, things that we take for granted as biologists, people don't realize that there's 7 different kinds of woodpecker in Florida.
Right.
A, who cares? And B, how cool.
I think it's cool. Exactly. So
yeah.
See, yeah.
All right, another question, and this one's kind of interesting. It's from Metul. And why don't thunderstorms moving off the coast of Florida begin to rotate and become hurricanes like their counterparts off the West African coast?
Great question. Two reasons, or actually, let me start with this. First of all, sometimes they do. I might have just blown people's minds like, wait, what did he just say? Sometimes they do. If it's a large enough complex of storms with a low enough pressure, believe it or not, it can develop into a storm. It's happened both ways. It's happened on the West Coast and in the Gulf, and it's happened on the East Coast and in the Atlantic. We had a tiny little baby Tropical Storm Emily, from a couple of years ago. And the thing was so tiny, it developed off a little batch of storms that was off our coast. We actually made fun of it. It was so small. And we were like, oh, there it is out in the Gulf. And the next morning, they went, it's a tropical storm. There it is. And it came ashore. It was so tiny, it could have fit under the Sunshine Skyway Bridge. And it came ashore in Manatee County. It triggered one tornado and actually tore up a greenhouse, and then it fell apart. That was it. So the answer to that question is it can happen, but it's rare, and here's why. Africa is massive. And so instead of thinking of it as a complex of thunderstorms, think of it as a continental air mass. And it comes off the coast of Africa as this massive blast of moisture and thunderstorms. It's not just thunderstorms. It's like a big low pressure area coming off the coast of Africa. We call them tropical waves because a wave is more pronounced. It's more of, in your mind, you go, oh yeah, it's a long wave of moisture. That's why. That's the simple answer. Coming off the coast of Africa, big wave of moisture. Then it's just a matter of, will they spin? Will they not? Will there be too much dust? Will there not? Will it get into a good area where there's not wind shear, warm water? That's what we do. We track all that.
So it can happen, and that is fascinating stuff.
Yeah.
We have a couple of questions along the same vein, so I'll save that.
And by the way, Faye kind of did that. Sorry to interrupt, but by the way, Faye kind of did that. Faye was a cluster of thunderstorms a week ago out towards Louisiana, and a little swirl. I actually posted it on Twitter. Too bad I don't have time right now to pull that up. I posted it on Twitter about a week ago. I was like, hey, look at this little swirl. I think I posted it on my professional Facebook page, by the way. I don't know if anybody follows that, but if you do, I think I posted on there. I said, hey, check out this little swirl. That went all the way across Georgia, South Carolina, North Carolina, and ultimately became Tropical Storm Faye. Crazy.
We can birth some systems.
Yep.
Florida can. All right, another question from Pindy. What causes sudden changes in temperature and wind gusts? Sometimes meteorologists don't have time to predict wind gusts in the summertime. Sorry about all the S's.
Okay, I think I know where the question's coming from, and that is a great question and pinpoint spot on for the Florida climatology. All right, so thunderstorm goes up. What will happen is, in our climate, all this warm, humid air rushes up into the sky. It cools, it condenses, and a thunderstorm forms immediately. Sometimes so fast, you'll be looking outside and it's sunny. The next minute, 10 minutes later, you have a thunderstorm over your house. We've all seen it if you live in the Florida climate. What will happen is it will go so high up in the sky, it will tap into the really, really, really cold air, hence why you can get hail falling down from the sky. And this thunderstorm will produce all this rain and it will crash down to the ground. So I showed some slides earlier on of that big rain shaft coming down. When that happens, it pulls the colder air with it. Sometimes you get the hail, but at the very least, what you'll get is you'll get this blast of air rushing down to the ground, and it will send out cooler air all along the ground. You'll get the wind gusts, sometimes damaging, sometimes where we call microburst. You might have heard of microburst. And you'll get shelf clouds from that. You can see the picture behind me. And you'll get the gust of cooler air. So if that's what they're referring to, that's what happens every day in our climatology. It's just a matter of, are you near that? If you're talking more on a large scale, like how come the temperatures cool down quickly in the wintertime per se, or in the fall, that usually is going to come from a wind shift from the north, bringing cooler continental air from the north, and cold fronts. So those are your differences. And by the way, in the wintertime, sometimes even something as simple as wind direction can make a big difference. If it comes from the west off the Gulf and the water's cooler, it can get cooler pretty quick. If it's coming from the east over warmer land, it can stay warm.
So when that cold air comes crashing to the ground and then flows along the ground, is that what y'all refer to as the outflow boundary?
Bingo.
Okay.
You will hear us talk about an outflow, and the boundary, outflow boundary, is the leading edge of that cooler air moving towards you. Sometimes you'll also hear it referred to as a gust front, a blast of cooler air headed towards you. And again, that's basically this picture you see behind me. That's the leading edge of cooler air racing away from the storm.
All right. Denise would like to know, is there a bulge in the Gulf that affects the pressures, or do highs and lows create a bulge in the water?
Oh, that's a great question. So she must be on top of things when it comes to Gulf climatology, because yes, there are bulges. This is really kind of getting to like 2 and 301, because this is fascinating stuff. A lot of people don't realize that water levels fluctuate. They can go up and down. And although it might be small changes, we can detect them based on satellites. And yes, it has to do with water temperatures and pressures and winds. I have a slide. Sorry, I'm going back. Everybody look away. I have a slide. There it is. Can everybody see this slide?
We got it.
Okay. This is a great one to answer this question. This right here are what we call loop current eddies. So when the Gulf Stream always comes up from the south out of the Caribbean, makes its right-hand turn, heads around southern Florida, occasionally you'll get a loop current, and occasionally it will even come all the way up like this, okay? But every now and then, it'll break apart, and the Gulf Stream will stay down here, and a little piece of it will come off like this, okay? And when they do, there's going to be little batches of warmer water around these loop current eddies. And you will get fluctuations in the height of the water level with those. That's what it is. And there is more to it, obviously, but that's a great question that would take you into almost like a level 3 or 4 class on water levels, sea level, currents, water temperatures, salinity levels, all kinds of things. But
All right, we'll save that for Weather 201. How about that?
I did an entire talk, James, on just the Gulf of Mexico. A group of kayakers wanted me to come in and give a talk about tides and the Gulf of Mexico, because they found it fascinating. When they would go out there, they'd get really weird, weather impacts. And they go, well, we hear you talk about marine winds, but we go out there and sometimes we get like these little microclimates. And so I did an entire talk on nothing but the Gulf of Mexico for them. And it took an hour and a half. That's how much goes on in the Gulf of Mexico. It's fascinating.
Well, of course, we're Brooker Creek Preserve, and we're the upland and freshwater wetland preserve in Pinellas County. Our sister preserve is Weeden Island down in St. Petersburg, and they also have a natural history program, and we could marry those two. But let's keep going on with some of these questions. I know everybody wants to get on with their day, but I want to get through the questions because this is so fantastic. James would like, not me, would like to know, why do the winds circulate differently with high pressure and low pressure systems?
Very good question. I'm going to keep these shorter since it sounds like we have a lot of questions. So I'm going to answer this with, it's the Coriolis effect. It's essentially where you have air that moves in different directions depending on which side, or I should say, on which side of the equator you're on, northern or southern hemisphere. So in the northern hemisphere, your Coriolis effect will cause low pressures to spin one way and high pressures to spin one way. In the southern hemisphere, a different way. That's a more in-depth conversation too, but that's the simple answer.
Cool. All right. Here's somebody with a very, very localized question. And, you know, some of us, I grew up in Pinellas County, I get this. Is the elevation of the ridge in Pinellas, in Seminole in particular, close to the intracoastal, the reason that we don't get as much rain as a couple of miles away? It seems like it goes right over us and rains in the east.
This is an easy answer, but you might not like my answer. No. I get that all the time. I get it all the time. And the funny thing is, I get it on the other side of the bay too. I hear from somebody in like Apollo Beach. Is it because I'm in the flat lowlands near the swampy area of the bay why I don't get rain at my house? Is it because I live north of Tampa Bay why I don't get rain at my house? Here's the real answer. And it's such a bummer of an answer. I hate to be honest with this because it's such a deflating answer, but the real truth is the Florida climatology is it feels like you're always missing out on rain, when in reality, if you were to put a rain gauge at your house and track the rain over the course of 5 to 10 years, everybody averages out about the same. But day to day, week to week, month to month, and even year to year, there are variations from Largo to St. Pete to Clearwater, Clearwater to Tampa. You see my point?
Absolutely.
So,
yep.
It's not a fun answer, but yeah, that's the real truth is it varies. I was at work the past couple of days and I was so busy I wasn't at home. I have a rain gauge outside. I didn't even know it rained at my house. I got home, I was like, I have a half an inch of rain? When did that happen? And I'm a meteorologist.
Now, I think you mentioned the pop-up showers that happen. Is that more of a factor of the sea breeze and the offshore, that collision? Is that kind of what causes the pop-up showers in the summer?
Yes, what causes the pop-up storms will be bay breezes, sea breezes that come from the Gulf. So bay breezes come from the bay. And that's what causes your deferring temperatures. So as the air that's cooler over the water runs into the air that's warmer over land, you'll get the collisions, which cause the air to move up, which causes the thunderstorms. Then from there on out, you get the outflows. So one thunderstorm pops up, it causes an outflow, it goes rushing out because that air is cooler. Now it runs into warmer air. So guess what it does? It causes a domino effect and it triggers another storm. Now that storm pops up, it causes an outflow and it runs into the previous outflow. So guess what it does? It causes two more storms. Those two storms pop up, domino effect, boom, 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 boom. That's what happens. The reason we haven't gotten into our traditional summer pattern the past week and a half is because we have such a strong onshore wind from the west that even when those storms are popping up, it's just kicking them off to the east. That's all it's doing. When that dies down in about a week from now, you're going to see us get back into our more traditional pattern of storm going up, it gets really big, and then two more pop up around it.
And that kind of leads us to another question we have from Sandy. Are we in a drought because of this?
We're not, luckily.
Are we in a drought because of something else?
Luckily, we're not in a drought. We're very lucky that we had, I'm trying to remember back, I think it was dry February, wet March. Don't quote me on this though, I apologize. Even as a meteorologist, I don't memorize everything, but I think it was something like we had one spring month that was dry, one that was really wet, and that saved us. So then we didn't go into a drought there. And then, yes, we have been relatively drier than average the past few weeks, but what saved us was June was so wet. And so we kind of got lucky. So what's happening right now is in typical Florida climate, it's almost like it's fixing itself. A little bit of dry. Whoop, we got lucky. We got a little wet. Oh man, we got a little dry. Whoop, we got a little wet. So yes, right now we're running a little dry, but don't worry. Florida climate, you got to love it. It fixes itself. In about a week or two, we're going to be sitting here going, oh my God, I'm so sick of all these thunderstorms.
Excellent. And just to kind of finish up, or where the questions are beginning to slow down, and I think folks are beginning to get on with their day. Really good question. Let's see if we can wrap all these together. We have someone wanting to know what's the most exciting recent technological advancement that you have that you're using right now? Like, what's the coolest, newest technology that you have that you're working with?
These are good questions.
That's our audience. We got the good people up here in our audience.
These are good questions. That's a great one, because just like smartphones and everything else, our business is advancing so much. Not only do I have to go to conferences constantly to keep up to date, not only do I have to read a lot, not only do I have to, keep studying, the advances are so amazing that a lot of times we'll tell people on TV, but I don't think people quite get how amazing they are. I would say the most recent two advances are GOES 16 satellites that, thank goodness, if anybody ever wants to dog out the US and say that we do a lot of things wrong, which, hey, we do, but the one thing we get right is we spend lots of money on weather research, and we put up satellites and we make it available to everybody in this country. We have got the most amazing satellite technology. So I can tell you what the winds are like, what the water temperatures are like, and every little thing that's happening across the entire Atlantic basin. The second most amazing thing is we continue to not settle on radar technology. We continue to strive for better. We're like, we have good, we want better. And I don't know of too many other countries in the world that do that. They don't spend as much money on their citizens. They don't put as much money into their technology for their country, and we do. So dual polarization radar was being researched the past 20 years, and it came along, and then companies in this country started building them. And luckily, stations like my own and companies like my own invested in it. And we started investing years ago. You had to, because it was going to cost millions. And we were one of the first stations in the entire world to put in a dual polarization radar. And basically what that allowed us to do is not just see a 2D view out into the world and see things falling. We were able to get a 3D view. So now we can detect better wind measurements. We can detect better on, like, where's the hail? Is it falling? How big is it? How much rain is falling? Which then in turn helps us with flood forecasting, flash flooding. We knew exactly how much rain fell in Harvey, whereas 10 years ago we wouldn't have. See, that's the other thing too that's making it hard. It's hard to compare past history to current because we're so much better now. We couldn't have told you 10 years ago how much rain fell exactly in Harvey, but now we can. So I'd say those two things, dual polarization radar, and we've now put up a lot more of them across our country, and GOES 16 satellite. And we show those every day, by the way, on Bay News 9.
Very cool. Got a good one from Luke, who probably needs to get to his lunch soon. He's 10 years old, and he would like to know something that I would also like to get my head around. What's the difference between dew point and humidity?
Fantastic question. Luke is a young genius.
Mm-hmm.
Because more adults need to ask this question. If Luke watches me on Spectrum Bay News 9, he will know that I am a huge advocate for hitting on dew point, dew point, dew point, dew point. I talk about it all the time, and I've told everybody else on our staff, talk about it. Because through the 60s, 70s, 80s, and 90s, No meteorologist on air talked about it. They would just say, oh, it's a humid day and there's the relative humidity. Relative humidity is just a ratio. It's just a percentage. If somebody says, but I have 100% humidity at my house, do you realize you could have 100% humidity in a cold Arctic climate when it's 10 degrees? Does that mean it feels humid outside? No, of course not. So it's just a ratio. Dew point is what matters. Humidity is taking the ratio between where your temperature is and where your dew point is. But the dew point is the direct measurement of how much moisture is in the atmosphere. That cuts right to the chase. And so all you have to do then is look at a scale. And since I don't have one prepared for you, essentially I'll give you the scale. When you get to about a dew point of 70, it's muggy. There's a lot of moisture in the air. When the dew point drops below about 50, it's getting quite a bit drier in the air. So you'll see dew points in the summertime across our country in the 50s, 60s, and 70s, very common. Here in Florida, our dew points stay in the 70s nonstop for 6 months out of the year. That's why everybody thinks of Florida as sticky, muggy, humid. So when we say things like, it's humid outside, it's muggy outside, oh, the humidity is high, do you know what we really mean? The dew point is high. And in our Florida climatology, the dew point stays high during the summer monsoonal rainy season. And then it fluctuates in the winter when we get intrusions of drier air. If you were to go out to the southwestern US, desert areas, drier climates, right? The dew points are always low, much, much lower. So low that a lot of times plants can't grow out there because they don't have enough moisture, hence the desert regions, arid areas. So yeah, that's a great question. You will see me show the dew point a lot and the dew point scale a lot on Bay News 9.
And is the 70 in the, you say the dew point is at 70, is that a degree?
70 and above.
Is that a degrees? Is 70 represent?
Yes, it's considered degrees. Yes, it's a little bit different from temperature scale, but it's similar reading. So if you say, oh, the dew point is 70 degrees, you know it's humid outside, you know it's muggy. If you say, well, the dew point's 76 degrees, it's even more muggy. There is more water in the air. And so a lot of times what you'll see is, you'll hear me say something like, hey, a tropical storm is on the way, so our winds are going to turn and come from the south out of the Caribbean, and that tropical wave or tropical storm that's passing by is going to pull a slug of tropical moisture up through here. So the dew points are going to rise all the way up around 80. Woo! When that happens, get ready. It's going to feel sticky outside. And then you'll hear me say in September or October, hey, guess what, everybody? The first dry front of the year is on the way. Now, it's not going to cool us down much, but our dew point's finally going to drop from 70 to 60. Woohoo! And that's when all of a sudden the rainy season starts to trail off. It might not be cooler outside, but it feels more comfortable. There you go.
Excellent. And let's just finish up with this kind of complex question that I quite like. You did a really good job of talking about the variables that go into the models for tropical weather, and especially with hurricane predictions.
Yeah.
And you added variables to see how the different programs would respond to those different variables. What do you think is the trickiest of those variables to add in? And has that changed now that we're having more maybe increased temperatures?
I'm going to answer this in two ways. Number one, I'll be honest with you, James. I'm not the best one to answer that, because when I was in the 90s, I wrote code for the National Weather Service. I actually wrote code for the SLOSH model that the National Hurricane Center uses to this day. And I worked with the scientists directly that wrote computer model code and determined what input to put in. They are the smartest people I've ever met when it comes to that answer. What do we put in? What do we manipulate? What do we try to tweak? So I'm going to give you, so that's the first part of the answer. is they're the brains behind it. And since I left that arena in the 90s, and now I've kind of gotten into the arena of more communicate outwards, the meteorology, I don't know if I'd be accurate in my answer, but I would say that probably two things are the most important: wind and wind direction, and moisture. Because within moisture are temperature and latent heat processes that happen between the ocean and the atmosphere that are very important on the survival of that hurricane engine. And winds are vitally important in determining structure and direction. So that would probably be my answer. It's somewhat of a broad answer, but I have a feeling when we tweak those, and since I'm not on those teams anymore that tweaks those, I don't know for sure, but I have a feeling over the years they're like, wow, that's really, when we hone in on those, we can really determine, you know, the differences in the hurricane paths. And by the way, while I'm thinking about that, I will say this, even though nobody's asked it, and even though I didn't hit on this, hurricane movement, we have come a long ways in the past 20, 30 years. We have come so far, we are so accurate that we are nailing it out of the ballpark on tracking storms compared to just 20 years ago. But intensity prediction has not come that far. We still don't understand everything out there in the atmosphere. So I want to make it very clear to whoever's left in the chat room that although I didn't cover that, I probably should have, that we still need to do tons more research. And they know that. National Hurricane Center knows that. Meteorologists behind the scenes know that. Researchers know that. We're trying. But we still don't understand why Irma strengthened so much and why Dorian strengthened so much. But yet some storms that took the exact same path didn't strengthen as much just a year earlier. There's obviously some things going on in the atmosphere that we still don't know about. And we're getting there. I would say like a class of like 301 or 401 would be to talk about nothing but modeling and the structure of what goes on in the atmosphere to predict long range trends. Because James, we do know about things that are happening in the earth, on the earth, I should say, that we just don't tell you about because it's too complicated. I can't get into a 2-minute weathercast on air and tell you about a THC pattern in the Atlantic and an AMO pattern and an MJO pattern that I've been researching since the 1980s and 90s, but yet I can't go into that level of research on TV. But I can tell you right now, we track things around the earth that will determine when we're going to get more tropical activity. And I can tell you right now, you better watch out because I see that pattern coming in late July to early August. And those are the patterns we watch for when all of a sudden we go from hardly any tropical activity to bloop, 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 tropical storms start popping up. We just haven't perfected why. Why is that happening? Why does it keep going around the globe? And every time it does, we get more activity. And how does it happen? But we know that stuff's happening out there.
Brian, we've got so much more to cover, it sounds like. And the comments are just flooding in about we want more, we want more. So we're so glad that you were able to join us today. We really lucked out in having Brian offered up to us when Extension Services reached out to Bay News 9. We're so lucky. We're going to have to wrap it up. Brian, I would like to ask you if you wouldn't mind to mute yourself and stop your video, but if you wouldn't mind staying signed in, I'm going to put up a final slide for everyone. Yeah, we just gotta bring him back comment. I'm going to put up this last slide. Want to thank everyone for joining us today. If you want to keep up with us and this kind of programming, today's presentation was part of Brooker Creek Preserve's Nature University, where we try and bring in experts to pitch things a little bit higher because we know you guys are really engaged and obviously have fantastic questions. Share your knowledge with others is what we always advocate for. To find out about more programs that are coming up, like us on Facebook. Right now, that's the cleanest and easiest and least expensive way to get information out to the general public. It's Brooker Creek Preserve Environmental Education Center. You got to get that whole thing in there. This summer and spring, we've been offering a series called Florida Supernature. These are 1-hour lectures that I've been doing on mostly botanical subjects, but we've also dipped into insect biology and other topics. To finish up the month, we've got 3 orchids this week, epiphytes the following week, and ferns after that. They're every Wednesday at 2 o'clock. I can't thank Brian enough for joining us today, and thank all of you for joining us. So with that, I'll say goodbye. If you have any questions going forward, you can email me here at my UF address or the address that I provided right at the beginning. So thanks for joining us today, and we're signing off.
Thank you, James. Thank you, everybody. Appreciate it.
Thanks.
Thanks, Brian. Hello.